In this video, we are going to be looking at the factors affecting rate of chemical reaction. And before we do that, what is rate of chemical reaction? Before we talk about this factor, what is rate of chemical reaction? When we talk about reaction, rate of chemical reaction, all we are dealing with is the changes per unit what time. That is to say, change in the quantity of the product per unit time, or change in the quantity of the reactant per unit time. That is what we mean by what? Rate of chemical reaction. For every quantity that is used up any quantity of the reactant that is used up in a chemical reaction over time, we use that to assess the rate of chemical reaction. And the rate of chemical reaction can be calculated by this formula, that is rate equal to what? Change in what? Reactants. Change in reactants, that's quantity of the reactant over time taken. Now, where you're dealing with could be mass, change in mass over time taken, change in volume over time taken. That is, all of them has to do with per unit what? Time. Change in quantity of the reactant or change in product per unit time give us what? Rate of chemical reaction. Now, there are some factors that affect rate of chemical reaction, which we have already listed here, and we're going to go into details. But before we do this thing again, we need to understand what we call the collision theory. According to collision theory stated that for a reaction to take place, there must be an effective collision. That is, an effective collision. There must be an effective collision according to collision theory. According to collision theory, every particle in a reaction is always in continuous collision. They are colliding with each other continuously, and only the collision that has enough energy to form a product can only take part in the chemical reaction. And those ones that have enough energy, is the one that form what we call the products. Now, for a reaction to take place, there is what we call an energy barrier or activation energy. This activation energy is the minimum amount of energy which must be overcome, or minimum energy which a reactant must possess for a reaction to take place. So this energy, why we regard it as energy barrier, because it's the energy that must be overcome, because if this energy is not overcome, reaction cannot take place. So during this collision of particles, they tend to acquire the one that has enough energy to overcome this energy barrier takes place in the chemical reaction. So there are basic things that can cause increase or decrease in the rate of chemical reaction. Anything that can influence these three basic things can also affect chemical reaction. And all these things listed here can influence one or two or three of these factors to make the reaction to be fast or slow, as the case may be. So one of these things that must be influenced, anything that can influence the energy content of the particles, anything that can influence the energy content of the particles can do what? Affect the rate of chemical reaction. Another thing, anything that can influence the frequency of the collision of the particles can also affect the rate of chemical reaction. And finally, anything that can affect the activation energy can also affect the rate of chemical reaction. These are the three things that can be influenced. So all these things listed here influence one or two of them in one way or the other to make the reaction to be fast or slow, as the case may be. So number one is what? Nature of the reactants. That is what we're looking at now, the factors that affect it. Now, nature of the reactant. How does this nature of the reactant affect any one of these? Now, the nature of the some compounds or metals, they have higher energy level. They have higher energy level. For example, something like sodium metals. When sodium reacts with water, is very, very fast and very, very spontaneous. Unlike when something like calcium is reacting with what? Water. Is different. This is because of the already existing energy content in these compounds, in these atoms or elements. So in the atom of sodium, the energy possessed by it is so high that when it reacts with water, the liberation of hydrogen will be faster than when calcium is reacting with water. This is because of the nature of the what? The reactants. We're talking about the nature now. For example, again, we look at ionic compound like electrovalent compound that form ions. When they dissolve in when they dissolve in water, they form ion easily. Or when they want to form bonds, what happens that they can form ion easily because of the nature of the electronegative, because of the electron positive nature of the sodium, for example, and because of the nature of the electropositive nature of the sodium, tends to what? Attracts electrons. Tends to do what? Combine fast with what? Highly electronegative um, elements, forming what? A compound faster than when we have covalent bondings where energy is required. For example, sodium combining with chlorine does not really need any kind of extra heat to make the reaction to take place, because they are the state or nature of the what? The reactants. Now we go down to what? Concentration. Now, what I want to point out here is that in nature, it depends on the energy content. This energy content affects, helps to what? These are one of the things I listed out earlier on that can also be affected. Anything that influences the energy content makes the reaction to be fast, like what we have in sodium and chlorine combining together. That makes the energy content, because of the energy level of the two um, elements that combining or atoms, it makes it to be what? Faster. Now, the other one, we're talking about concentration or pressure for what? Gases. That is, when you talk about gas, we talk about what? Pressure. So, concentration or pressure for gases of the reactant. Now, when we talk about concentration, what does this concentration affect? Concentration influence the what? It influences the what? Frequency of the collision. Frequency of the collision is affected by concentration. Increase in concentration increase the rate of collision. The frequency of the collision will be increased, thereby leading to what? More reaction to take place. For gases, increase in pressure increase the frequency of the what? Collision, making the reaction to be more effective. I want you to know this, that the concentration now affect the what? The frequency. Why the nature of the content influence the what? Energy content, determined by the energy content of the what? Reactants. When the energy content of the reactant is high, they possess high level of energy, it makes the reaction to be faster. That's where the nature of the reactants play a very important role. While this other one influence the what? Frequency of the what? Pollution. Pay attention to that. The next one, we're looking at the surface area of the reactant. Now, when you have a powdered calcium triazoxide carbonate, the reaction will be faster because there is high surface area for the reaction. For example, now triazoxide carbonate reacting with an acid, the increase in surface area makes the reaction to be effective with dilute hydrochloric acid, making the production of carbon 4 faster than when you have granules. Because of the low surface area, it makes this reaction to be slow, gradually. So the reaction will be gradual when it's granules, as against when it's in powdered form. So what does it mean? The surface area, what does it affect? It affects the what? The rate of what? Collision. It influences the what? Rate of collision, because when it's in powder, the impact of the dilute acid to the powdered triazoxide carbonate will be high than when it's what in granules. So making it to be what ineffective when it's in granules. But when it's in powdered form, the reaction will be faster. That is why this other one also influence what frequency of the collision. Now we go back to we move down to the temperature. What does this temperature influences? It also influences the what frequency of the collision, and the second one is influence the energy contents. These are the two things the temperature influences. Increase in temperature increases the collision and also add up more energy for the reaction to take place. Note that this here we have two things that influences. I said what it has the energy, and what collision. Frequency of the what collision is also affected by what temperature. So the temperature plays a very important role by influencing the energy content and what frequency of the collision. Now we'll get to the light. Now, what does light do? In light, what does light do? In light case, in the case of light, just like maintain and chlorine, the reaction in this reaction, presence of sunlight makes the reaction to be effective. That means increasing the what energy content. It increases the energy content of the reaction, therefore by favoring the what the reaction. Now going down to presence of catalyst, the basic factor affected by what catalyst is the energy of that is the activation energy. It influence the what activation energy. How? Catalysts reduce the energy. It reduce the energy level of the reaction. So by that, the energy part will be lower. For example, let me see if I can give you a sketch of what I really mean. For example, where we have a reaction part that will go like this. This is the activation energy. Activation energy. So when catalyst is used, it tends to lower it, making the reaction to take a lower path and faster. The energy requirement will be dropped, will be reduced. The activation energy will be reduced, making the reaction to work to be faster. These are some of the things I want you to note very well, that catalysts affect the activation energy, light affects the collision, the frequency of the collision and what energy. At the same time as temperature also affects the what energy content and the concentration. Energy content and what rate of collision. Now concentration affects what concentration of pressure and influence the what the frequency of the collision, while the nature of the reactants influence the what energy of the particles, energy content of the particles, because naturally some of these elements or atoms, they have their own already existing energy in them that makes them to be faster in some reaction. That's when you look at the activity series of the elements, you find out that some of them they are high and some of them are low. For example, anything lower below hydrogen, any elements lower below hydrogen in the activity series cannot liberate hydrogen, but any other ones higher than hydrogen can liberate hydrogen. So this is where I'm going to stop for today. Thank you so much for being part of the class. If you're joining for the first time, remember to subscribe. And if you have any question, you leave your question in the comment section. I will always attend to you. And then remember to share and like. Bye.